It's a little small, and we'll get started here. So, all right. So this question, it says to find two things. It says to determine whether it's growth or decay. This number determines whether it's growth or decay. The number in parentheses. If it's between 0 and 1. I'm putting this in the wrong place. So if the number is greater than 1, if A is greater than 1, it's growth, and if it's between 0 and 1, it's decay. So this is decay.
Okay.
And then to find the y-intercept, you set x equal to 0, and in this case you get y equals 3, 0.25 to the power of 0, which is y equals 3 times 1, which is 3. So your y-intercept is 0, 3. I'll try to organize that better on the next couple here.
Okay.
I want to do 3 next. We'll come back to 2.
Okay.
So 3 is y equals 0.1 times 10 to the power of x. So this number in parentheses, number A, is greater than 1. That means it's growth.
Yeah.
And then to find the y-intercept, you're going to put x equals 0. So you get y equals 0.1, 10 to the 0 power. 10, anything to the 0 power, any number to the 0 power is always 1. So this is y equals 0.1 times 1, which is 0.1. So your 0, 0.1 is your y-intercept. All right, let's go back to 2. 2 is kind of an exception here. It's not written in the form of the previous ones. So you have a choice here. When you have negative exponents here, the first option is to use all sort of alternative rules. The second option is to convert to positive exponents. Which do you think you're more likely to do?
Probably convert to positive.
Okay, so to do that, you get 1 over 6 to the power of x.
Okay.
Does that look okay for you?
Yeah.
Since this number is between 0 and 1, it's decay.
Mm-hmm.
And then to find the y-intercept, you put x equals 0 into the equation, so you get y equals 2 times 6, or 1/6 to the 0 power. Anything to the 0 power is 1, so it's 2 times 1, y equals 2. Anything unclear about that?
No, I got it.
Okay. Y equals 3e to the x. So e is your base of your exponent. The value of e is approximately 2.7 something. That number is certainly bigger than 1, so this is growth. And it's as simple as that. To find the
Yeah.
y-intercept, you're going to put x equals 0 into the equation. So you get y equals 3e to the 0. Y equals 3 times 1, so y equals 3. Your x-intercept is 0, 3.
Okay.
All right, so next group of questions take slightly longer to do, but they're related to this. You have to do some of the same things. Let me get that going here. We got number 5 here says y equals 1/2 to the power of x plus 1. It says describe how the graph of each function is related to the graph of its parent function. Then find the domain, range, and asymptotes. Okay, so quite a few things here. The parent function for this one is y equals 1/2 to the power of x, I believe. It could also be that it's y equals 2 to the x. I don't know if you have any reference for that. It would potentially help for this one.
It's like the asymptote things.
Well, I guess no, I mean, do you have the solutions to this? Did the instructor provide them?
Oh yeah. I'll just
Because it would be helpful here, because there's a couple of things that happen based on which one of these it is.
Okay. Number 5. The parent graph is y equals 3 to the x power.
Or this one? Oh, you know what? I'm doing 6.
Well,
I see. Okay. I'll come back to this. So 6, I'm sorry. So 5 is y equals 3 to the x plus 2. So the parent for sure is 3 to the x. And the graph of that, it goes like this. It's a growth function.
mhm.
All right. That's interesting. Okay. So then the next thing it asks for is what happens? What are the transformations? So the only transformation you have is this right here. The plus 2 means it shifts up 2 because it's outside of the parent function. And that's why it goes up 2. The
Yeah.
domain of all of these exponential functions is all real numbers. This is always true for the domain. For logarithms, it's the flip of this. The range is the following. It's either it's either minus infinity to the horizontal asymptote, or it's the horizontal asymptote to positive infinity. And this is if it's there's the graphs that you're looking for here for this one would be if it's like going up or if it's going down. These graphs tend to look like this or like this.
Okay.
So we already know that it goes up like this. So really we need to find the horizontal asymptote first, which is what it asks for. So now I'm throwing a lot at you in this question. The horizontal asymptote is always y equals the vertical shift. So what is the vertical shift in this problem?
2.
2. So it's y equals 2. So that tells us which one it is here. So the range ends up being 2 to infinity because this thing is a growth function. It goes, goes up like that.
Got it.
Okay, so now we'll go to 5. The parent function, can you check on that for me? Is it, I'm sorry, this is 6. If it's, I guess,
It's 1/2.
okay, good. All right, so the 1/2 graph looks like this. It decays. Okay, so the only transformations in this particular problem from this was this right here, the x plus 1. So because this is inside the function, it moves it left or right. So it ends up being left 1 unit. The domain is always minus infinity to infinity on exponential functions. The range, though, it depends whether it's which direction it's going. We really should find the horizontal asymptote first. There's nothing being added out here, so that is the horizontal asymptote, y equals 0.
Okay.
So the range in this case, it's either minus infinity to 0 or 0 to infinity. And it has this sort of shape to it here.
So it's 0 to infinity.
Yeah, it's this one. Good. All right, number 7. Y equals minus parentheses 2, x plus 2. So the parent function here is y equals 2 to the x. And that looks like this. It goes up. But there's a lot of things that are going to change here. So we have to deal with this plus 2. And they have to deal with this negative. So the plus 2, because it's inside the function, there's really implied parentheses here. That is left 2 units. If it were minus 2, it would be right 2 units.
Okay.
The negative is a flip over the x-axis. So that means this thing went left 2 units. So everything goes left 2 units. But more importantly is it flips down. So it looks like it's got this kind of shape now to it, where it's going down below the axis. So now we can answer, well, what's the domain? Well, the domain is always all real numbers. Always, always, always. The horizontal asymptote is whatever the vertical shift is there a vertical shift? No, so it's just y equals 0. So your range this time, it's either minus infinity to 0, or it's 0 to infinity. And this time it's this one, because you can see here it comes, it's goes down as far as we want, but it comes up to 0.
Yeah.
Okay. Moving on here to number 8. So number 8, 5 to the 4th equals 625. So I'm going to write the answer, and then you will see how, I guess you will see how you will see what to do here. So we have log base 5, 625 equals 4. So this is this number comes here, the 5 comes down here, and the 6 is right there. So what I usually suggest is to have a reference in your notes, so you can just see where to move things,
Okay.
because it's awkward otherwise. You can easily put the wrong number in the wrong place, especially in like a multiple choice setting. So e to the 0 equals 1. This one's a lot harder because you have to know about natural log. This is log base e of 1 equals 0. So again, kind of like this goes here, this 0 goes here, and this 1 is here. Log base e though, and this is really weird, I think, to write, but most textbooks just use natural log now instead of log base e. These are the same. This textbook just probably emphasizes log base e to do this problem.
Yeah.
So, okay, there really isn't much to say on those. So now 10, 11, 12, and 13, these are all numerical problems, and you do get a value when you're done. Log base 2 of 8. So if you had a calculator, are you allowed to use a calculator on this?
Yes.
Okay, so what you could do is you could use well, if you have a TI-84, I should say it this way,
Yeah.
you can find the base 2, and you can just plug this in. If you didn't, you can do log 8 over log 2, and it will give you the same result,
Okay.
which ends up being 3. So if you have your calculator, I would suggest trying out these problems, 11, 12, and 13, real quick.
Got it. How do you get the log 2? Or should I just do it?
It's under, I believe it's under math or something. Let me I can find it.
Yeah, I got 3. All right. Let me look for it. Math.
It says math A. I don't know. Math, yeah, math button.
Oh. Yeah, I got it. Log base. I got 1 for 11.
So 11 is 1. If you get a fraction or a decimal, I'm sorry, if you get a decimal, you have to be able to convert it to a fraction. 12, you'll see that it's log base 5, 1 over 125. This equals -3. 13, log base 11 of 1 equals 0.
All right, I got those.
All right. Okay, so 14 through 15 are similar to 5 through 7 because you're asked to do essentially the same thing. So 14 is y equals log base 3 x minus 1. So you have to know it asks for the parent function here. So the parent function is a log, base 3 of x, and it has this sort of shape to it where it comes up, crosses, and goes that way.
Okay.
So this time we're doing a slightly different order. The range is always all real numbers. So the domain for growth functions is always all real numbers. The range is always all real numbers for these. So rather than finding the horizontal asymptote, you find the vertical asymptote. The vertical asymptote is whatever makes this equal to 0. Whatever makes x minus 1 equal to 0. So that is x equals 0.
Okay.
So now the domain, it's a choice again. It's either the vertical asymptote to infinity, or it's minus infinity to the vertical asymptote. So in this case, you're choosing between 0 to infinity. I'm sorry, I don't know why I wrote this. This is x equals 1, this x equals 1, so that's 1 to infinity, or it's minus infinity to 1. So it's this one here, because you can see it goes to the right. This is moved right 1 unit. I guess we need to oh, it doesn't say to list the transformations this time.
Yeah.
Should I go through anything on that again, or move to the next question?
We can move to the next one. I got
Okay.
it.
Oh, you can also graph these on Desmos, and you'll see everything that I'm talking about. So if you need sort of a confirmation that what you're doing is correct, it is there.
Yeah.
So the parent function is again log base 3 of x, and it has that shape where it goes up and to the right.
Okay.
Okay, so now this plus 2, this x plus 2 here, this means that when it goes left 2, the 1/2 is a vertical compression by 1/2. So no, it doesn't ask for that, but that does help here. So the range is always all real numbers. The vertical asymptote here is whatever makes this equal to 0. So x equals -2. That comes from that. So our choice for the domain is either minus infinity -2 or -2 comma infinity. And you can, since it went left 2, this just moves left 2. So you can see it looks like something like that on the right there. So the domain is this one here.
Yeah. Okay.
16 has a couple of more things going on with it. So y equals 1 minus log base 2 of x. If I rewrite this, it will greatly help how to do this problem. There's really a plus in front of the 1. Moving over here, it helps to demonstrate what's happening. The parent function is log base 2 of x, which goes up and to the right again. So now what does this negative do? This negative is a flip over the x-axis. The 1 is a shift vertical, up 1 unit. So what is the range for these?
All real numbers.
All real numbers. The vertical asymptote is whatever makes the inside part equal to 0. So that's just x equals 0.
Okay.
This negative flips it, but it still has, it's not moving left or right. So the domain is only affected when you move left or right. So the domain here is either minus infinity to 0, or it's 0 to infinity.
0 to infinity.
Yep. So it's this one here.
Got it.
All right. So now, after, like, it seems like there's problems that are graphing problems, and then you just go back to like, here's a numerical problem to do, which is what 17 is. So 17 says log base 2 of 4 plus 3 log base 2 of 9. And they want you to write it as a single expression. Usually you expand first and then go backwards, but your book's doing it in reverse here. There's several properties that you might use. The first one you're going to use here is that if you have a number out in front, actually let me rewrite this. If you have a number out in front, like which we have here, 3 x, this equals log base b x to the n. So essentially that n comes up as an exponent. So this 3 is going to come up as an exponent here. So it's log base 2 of 4 plus log base 2 of 9 to the power of 3. Have you seen that before?
Yeah.
Okay. You can definitely simplify this if you want. It's log base 2 729, I believe. Log base 2 of 4. So now you can use the property that if you have log base b of a plus log base b of b, this equals log base b of a times b. So you take these two numbers here, because it's the same base, and it doesn't have to be numbers, but it is in this case. Whatever you're taking the log of, you multiply. So that's log base 2 of whatever 4 times 729 is. So
2,916.
16.
Yeah.
Okay, so that's your final there on that one. 18. 3 log a minus 2 log b. First thing here is when the base isn't written, it's 10. Oops, I wrote that in the wrong place. So in this case, it's 10. If it's ln, you don't have to write a base for this, but log usually you do.
Uh-huh.
All right, now the first thing you do is bring these exponents up. This is log base 10 a cubed minus log base 10 b squared. Now we have a different property because you're subtracting. So log base b of a minus log base b of b, when you're subtracting, it becomes a quotient. So you write a over b. So in this case, you're going to take a cubed and b squared, and you're going to write them over each other. A cubed over b squared. So here they come. And then it's log base 10 of that.
Okay. Got it.
That's it. That's it for those two. Now the next two problems are expanding. So we have log base 7 a over b. This is like a straight definition problem. It's the properties in reverse. So it doesn't matter that I'm using an uppercase letter here. It becomes log base b of a minus log base b of b. The top number comes first. The second number comes second. So you got log base 7 of a minus log base 7 of b. Oops, I wrote an uppercase a there. It should be lowercase.
Okay, I got it.
That's it. Nothing else to do on that one.
Yeah.
Number 20 is log 3x squared y squared. There's a base 10 when it's not written. So this is this problem uses the product to sum property. So if you have log base b, I'm going to write it this way, a times b times c, it becomes log base b of a plus log base b of b plus log base b of c. So in this case, your a is the 3, your b is the x squared, and your c is the y squared. This becomes log base 10 of 3 plus log base 10 of x squared plus log base 10 of y squared.
Okay. Not so bad.
A couple more things you have to do here. You have to move the 2 down and the 2 down, and that's using the property log base b of x to the n equals n times log base b of x. There's really only 3 of these, but they're sometimes used forwards and backwards depending on the problem that you're looking at. So it's log base 10 of 3 plus 2 log base 10 of x plus 2 log base 10 of y.
Got it.
So 21, 22, you can actually just punch right into your calculator, which I think would be worth you doing to get comfortable with it. I'll give you what do these have here? Yeah. $22 will not give you a nice number, but 21 will, I think.
All right. 9. Okay, I got 0.5 for 21.
Okay, I agree. 22, you have to, if you put in your calculator, you won't get a nice number because it's log of 5 squared when you move that 2 out in front plus log of 40. Okay, so this becomes log, actually I take that back. It's log 25 plus log 40. When you multiply these together, you get 25 times 40, which is 1,000. Log base 10 of 1,000 ends up being 3. So you actually could do that in your calculator pretty easily.
Okay.
If you wanted to, that's totally up to you.
Yeah.
All right, let's do 23 next.
Okay.
So that's 27, 3 to the x power equals 81. The goal here, is to get the base equal the base. So like, for example, 81 can be written as 3 to the 4th power. So if you can turn this thing on the left side into something 3 to the something power, you can solve this. So 27, for example, can be written as 3 cubed. And then that 3x just comes down. Is that something you've seen in class?
Yeah.
Okay, so when you have an exponent to an exponent, you can multiply. That's 3 to the 9x equals 3 to the 4. And so you set 9x equal to 4, and then solve x equals 4 over 9.
Okay.
That is the only one that you can set the base is equal. The next one requires you to do something totally different.
Yeah.
Which that's just the way it goes. So 3 to the x minus 1 equals 24. The only way to get an exponent out of a variable out of the exponent, let me write it differently. Variable out of exponent is to use natural log, or ln. So use natural log on both sides of the equation. And you can bring this x minus 1 out front. So it becomes x minus 1 in parentheses, natural log of 3 equals natural log of 24. So you can divide both sides by the natural log of 3. X minus 1 equals natural log 24 over the natural log of 3. And then you add 1 to both sides. So x equals natural log of 24 over the natural log of 3 plus 1.
Okay.
25 is somewhat similar to this one. Get a little more room here. So 25, 2e to the 3x equals 16. to the 3x equals 8 because you divide both sides by 2.
Oh, okay.
So the natural log of e equals 1. So you're going to take a natural log of both sides. E to the 3x equals natural log of 8. You can bring the 3x down. So you have 3x natural log of e equals natural log of 8. The natural log of e is 1, so you have 3x on the left side equals natural log of 8. X equals 1/3 natural log of 8. There's actually a little bit more you can do on this one. I don't know how far your instructor wants you to go, but 8 is 2 cubed. And so you bring the 3 out in front, so it ends up being 3 times 1/3 natural log of 2, which becomes natural log of 2.
Yeah.
Not sure. There's sometimes the instructors, I don't know how far they'd want you to go. But these are all different. I mean, hopefully you've seen these in class because this is just a run through of these questions. It's not really like, hey, here's how to do them for the exam, unless you get ones just like this. So we want to isolate the logarithm here, and we're going to divide both sides by 2. Now to undo a log, you have to use the base. So to undo log base b, you use b to some power. So you write 10 to the log base 10 of x equals 10 to the minus 2. On the left side, this undoes the logarithm, so it just leaves you with x. That just comes down. These two undo each other. 10 to the minus 2 power is 1 over 10 squared, which is 1 over 100.
Okay.
All right, so 27 through 30, these questions are much like 8 and 9. They're just the reverse of 8 and 9. Oh, I'm sorry. No. I'm sorry. I misspoke. All they want you to do is use this property. Log base b of x equals log x over log b. So you're just going to write log of whatever the number is, 16, over log of whatever the base is. The 3 goes there, the 16 goes there.
And you just leave it at that?
Like just like that. That's all it wants you to do. It says to rewrite. So we're just rewriting. Log base 2 of 10 is log base 10 over log of 2. 29 log base 7 of 8 equals log of 8 over log of 7. And then 30 log base 4 of 9 equals log of 9 over log of 4.
Okay, I just got to finish writing the last one.
Sure.
All right, I'm ready. 31.
Ella, you ready to move on to 31?
Yeah.
Okay. All right. So this one says to simplify and solve each equation, round to the nearest 1,000. So what I tend to do, what I like to do in these problems is to solve for x and then put it in the calculator. But here's what you could do. You could go to Desmos and you could put this into like y1, this into y2, and just figure out where they intersect. And if you're not sure what I mean by that, I can show you, but that would be one way to do all of these problems.
Can you show me how to use Desmos and like
Sure,
write that
sure,
in?
sure. So let me do this. I'm gonna new share. I'm gonna new share a screen with it open, and we'll just do each of these this way. So All right, new share right there. So you've got the problems, I've got the problems, and this one you're gonna go ln2 plus lnx, and then here you can go y equals 1. You can use y for both. That's probably a good technique here, and you just see where they intersect. There's the answer.
Oh.
I mean, it doesn't get much more difficult than that for this one. So do you need to get the numbers down?
No, I got it.
Got it. Okay. So I'm going to read the next one here. It's natural log of x plus 1. So I'm just going to unhide these. So y equals natural log x plus 1. What is it? Minus plus natural log x minus 1. And then y equals 4. I think that's what's, yeah. You just find the intersection. And you could always take a snippet of this for your instructor if you're taking a test, show them that you're using technology. I think that's a great strategy. All right, so the next one is natural log 2x minus 1. Let me put a y in front of it. Squared. And then this is y equals 7 below it. So this actually has two solutions. You'll see it hits twice. There.
Oh, yeah.
And there. Okay, ready to move on to the last one here?
Yeah.
All right, so 34, I'm just gonna write down my screen here. So I have 3 natural log x minus natural log 2, and y equals 4. And these all fit in the basically the window that you've got here. So it's really nice to have. Nothing more than that to do on these. We could do them by hand if you'd like, or this is good enough. You know.
Yeah, I'm good. That's all the questions we had to do. So
Great. Well, I'll send the notes out to you shortly, and thanks again for scheduling.
thanks. I'll see you soon.
See you next time. Bye now.